everybody. Thank you very much for joining us today. So we've got something super exciting lined up for you. We are going through some of the sessions that were lined up for Nodes, and we've got this as the Nodes extended session. So what we're going to be doing is we're going to have a few weeks of these, so these online meetups, where we're going to be covering some of our Nodes 2020 content. Nodes extended, and I'm super excited because I've got my wonderful co-host here, Nathan Smith, who's joining me. So those of you who watched out for pre-Nodes may have spotted Nathan. So he's back and he's joining me here as co-host. And we've also got a couple of amazing talks. So we've got Chris Eyre and Tim Reimer joining us, and they're going to be in a talk. So very quickly, before we hand over to Chris when he does his talk, and what we'll be doing with regards to questions is we'll keep an eye on the questions that come in. So please send your questions, and we've got a panel talk at the end. So we will get to those after we've done both talks. But before we hand over to Chris, I just quickly wanted to hand over to Nathan. So Nathan, please tell us a bit more about yourself. Tell us a bit more about your meetup group. Yeah.
Thank you, Lou. It's so nice to be here on behalf of the Neo4j community. My name is Nathan Smith, and I'm a senior data scientist at Lazarevic. I live in Kansas City, Missouri, and in the United States, right in the middle of the country. And I'm an organizer here of our Kansas City Graph Databases Meetup. And it's been a bit of a shift since we've had to go online because of pandemic precautions, but it's also allowed us to make some wonderful friends in different parts of the world. And we're really happy to be part of this event today, and really looking forward to the work that Chris and Tim have put in, and I know we're going to learn a lot. No,
absolutely. Really looking forward to it. So thank you very much for joining me, Nathan. And I think without further ado, we are going to hand over to our first speaker, Chris. So Chris, over to you.
Hi, I'm Chris Eyre. I'm a software craftsman at a company called Coherence. I'm based in the UK, in London. Right, okay, so the talk I'm going to give you today, when it updates, is about Contentful to Neo4j, which is linking a Contentful content management system to Neo4j. And I'll be going through the story of why I end up using Contentful and why adding Neo4j to it makes it so much easier to use. And again, this is the visual detail. So it's viewing Contentful data in Neo4j. So about me, I'm a software craftsman at Coherence. There's my Twitter handle, the book I wrote last year on software development. I mentor Elixir on Exerson.io in my spare time, and there's my blog and the GitHub URL of the open source utility that I'll be talking about. Now, there are three topics here in Contentful to Neo4j. Contentful is the content management system, which is a headless CMS that probably most of you don't know very much about, so I'll be spending a lot of time introducing it. The utility that combines them is written in JavaScript. I'll be talking a little in it, but not much. And then there's Neo4j, which normally I spend more time explaining, but since this is a Neo4j group, there's no point in explaining Neo4j because I'll be singing to the choir. Right, so let's go through the details here. So the question is, why would I be interested in this talk? And I have a CMS I want to query, and I need a queryable CMS, and which is a very specific thing, or I have a data set that I'd like to be able to put into Neo4j. So you can use my example of loading data from a content management system to load data from an external data set and put it into Neo4j. And I managed to get every single piece of data that I could from the content management system into Neo4j in a very easy to work manner. So the story goes back. So a few years ago, I was working on a project. I used to work for Pottermore, the Harry Potter website, and we were starting on a big change to the site. And we needed to build a CMS. And that's where the thing was. We suddenly realized we need to build a content management system. And then the team were looking at let's start writing one from scratch. Let's see how long it's going to take. And then I asked the big question, have we made the build versus buy decision? Which is kind of a key point to make on almost any project, is kind of rather than spend your time building everything from scratch, can you buy it in? So we had a quick look around at the various requirements we needed. So one of our things we have is that for our thing is we didn't want to have any infrastructure in the office. So everything had to be cloud hosted, and we wanted to be able to configure it completely via an API. Now, This is where we had fun with there are two forms in the market of content management systems exist. There is the traditional CMSs that have two UIs. One of them is for putting the data in, and another one is for displaying the data. Now, the problem with these are you spend all your time customizing the display of data part to actually make it not do what it does. So you end up spending your time fighting it. So this was kind of problematic. But then we found that there were some other CMSs that turned up on the market, and they're called Headless CMS. Now, Headless CMS has one UI for the entry of data, and then you get an API feed to get the data out. So it doesn't fight the front end. And the downside is you have to build all of the front end yourself, and that's where the fun part starts. So that's where the fun starts on there. So we decided to have a look through there. Now, at the time, there were just two candidates in the marketplace, Contentful and Prismic. They both still exist. They're both still out there, but Contentful was the one we chose. So I'm going to go through here, give them some details on Contentful. Now, it's cloud-hosted, headless CMS, and provides a user interface for content editors. Unfortunately, these slides, I took these screenshots a while back, so they may look a little different to the version I'll be demoing because it's been 2 years and they've updated slightly. But anyway, so here's the detail of what you have. And again, there's no UI for the end user. You have several separate APIs for it. There's one for content delivery, which is give me what this content is currently in the content management system. Content management is for you can programmatically put data into the content management system if you didn't want to use the API, or you can define the data structure. And these APIs are served either as REST or there's a GraphQL, which now exists, but when I wrote this utility, this didn't exist. So within Contentful, you have this concept of spaces. Now, a space is like a database. So you'd have your particular space, and a space is a database. It then has a content model, which is the schema of the data you have, which is you create a content type that builds your content model. So, for example, within a blog, you can have a blog post being a content type or an author being a content type. It then has content, which are instances of the content type, which can then also have be references to other content types or have various primitive properties. And then you can update media files, which originally they intended it for use of uploading images or video files. But we found out you could actually store zip files in there. And so we were actually able to have kind of a content management system that was allowing users to download a bundle of zipped documents. And we were able to build it straight into the content management system without having to build anything custom to do the work. So let's go for a demo of Contentful. All right, hang on. I have to get out my slides to do that. Right, so here is the Contentful. This is the Contentful user interface. So we have, there are several spaces out there, and this is a demo space that I've been using for it. So we have, at the top, we have a content model, content, and media. Now, the content model allows you to define what the types of data are. So you can have a blog post, a person, an update, and a blog post has a number of fields. So, for example, one of these fields must be described as one of the fields is marked. This is marked as the entry title. One of the fields is the key item of it, and this makes it the key. But for example, we can add details to it. So I'm trying to find out what kind of things I'm missing on the on the blog post, which let's kind of add a new detail to it. So I'm going to add a field to this content type, and I'm going to say I'm going to add a new content type saying I'm going to add an archive, because there are now lots of assistant things on there, and I wanted to say, is it a Boolean field? Is it going to be in the archive? So I've given it an archive field, and I've created a field. Now, by doing this, I've actually changed in the content of the structure of the data while it's in progress, and that's fine. I've saved it. It can have these fields in place. So that's the content. That's the content type. So go to the content model. So now I've got a blog post, and I've added a field to it. Then you can go over to the content and have an example of the content. So here's a blog post of Hello World. And if you go through the user interface here, and you've got the detail, I've added this field in there, and it's got archived, and it defaulted to I don't know. So as it's a Boolean, it defaults to to null. So you can divide it. So I'm going to archive it. I'm going to put an archive yes property on there. And thereby, by publishing the change, I have now got a content management system, and I've added a field to it entirely through the user interface. You can do this programmatically, and I'd recommend to do that for larger systems. But again, that's a different part of the thing, not covering the talk. And here you go. So there are the various content types on the blog post. So we have blog post there. So then we go back to and say, right, here's the list of content types on the blog. And then here is a media library. It's a media gallery that holds things in there, and they hold it in a content delivery network for you. So basically, you have everything you need for a content management system except the user interface. Now, you can plug it into standard static site generators, but that's the kind of the pieces there. So here, this is the details on it, and other settings you can do. If, for example, you can actually have various API keys on it. So you can actually give yourself a content management or a delivery token. So I've got this token, which I'm going to need later. It's got the space ID and this content delivery token, delivery API key. And Contentful has two API feeds. One is the preview and one is the publish. The idea of the preview is that we used to use it for our editors. The editors had a second version of the website that could watch the preview one. So any article, including stuff that hadn't been published, would appear on the preview site, and anyone that had on the published site turned up on the published site. And this is where the magic started appearing, because we had a thing that set up, and I'll go through this in a second, the details on a publication. We were generating the site, so it was a 1 second behind the previous site was updated, 1 second behind anyone adding content on the site. And when you published it, it was about 1 second between pressing the button and the site changing. Let's go back to the presentation. Let's find my right present button again. Right, so that's onto Contentful. Now, this is the workflow that we had on the details. So what we've got here is we have the content headless CMS, and we had a static sites generator that would poll the CMS. So every second we'd try and grab the details on it. Now, the static site generator would remember what the state of the site was beforehand. So it would then know what files had changed, and therefore, based on what the delta, it would then publish to S3 the new page it created. We then had a web server, which was fastly set to configure to read to the S3 bucket. And then we'd send a purge request to the CDN, which would actually then say, hey, there you go, we're going to actually publish your details. So we had a website that was actually able to and update within a second of any changes. And again, we had a parallel structure this for the preview sites. And that's the details. That's how we managed to get a ridiculously fast publication system. And this system worked well in production for a year. We had it growing, a nice simple way of doing so, and all of our content grew. And then the content, because we ended up having a very complicated system, the content editors started to claim there were bugs in it. So we had content types with some complex data types. So we had articles that had related articles associated with them. So each content type needed to have 6 specific other types of articles associated to it. Otherwise, the recommendation system didn't work. Now, when the site was small, all the content editors knew to do this so that it was easy and it didn't break. But we weren't told we were told, don't worry about putting any special validation on it. Let the content editors do it. But when the system, after about a year's worth of filling in data, we started finding things were broken. So there were articles that had less than 6 related articles, and it caused problems. And there was an argument over whether it was a bug or was it not working. So this is where we came up with the big problem. And the problem is I can't easily query data in Contentful, because Contentful was designed for publishing data and managing data. It isn't designed for searching. And then I suddenly realized that the entire content data in the Contentful space actually forms a graph. So my solution was, let's feed Neo4j database entirely from Contentful. And that's where the utility that I started writing came from. So starting talking about graphs. Now, this is always the classic one. When it says, is this a graph? The answer is no, it's a chart. It's not a graph. So here we go. This is the graph. Graphs have nodes and edges and details, and that's the magic that you can feed straight into and represent natively inside Neo4j. So this is where my tool came in. I have the data in Contentful. I have my utility sits in the middle and performs the transform and loads Neo4j. Now, I have a slightly different approach than most people about Neo4j. I actually go for a rather extreme approach. I delete the graph database and reload it from scratch every single time I need to work on it, because this thing doesn't update that fast. The content editors change it once or twice a day. If the website's slightly out of date, it takes me 5 minutes to rerun it. So it's done. I don't need to worry about backups. And if there's any problems, I can just rerun and get there. Now, there is some catch-ups that if I can't find my system tries to read through. Now, at the time I wrote this 2 years ago, it could handle every kind of content type that existed in Contentful. But since then, Contentful have added some custom types that I don't know how to handle. But the rule of this system is, if it doesn't know how to deal with a field, just skip it and carry on. Do the HTML thing. If you don't know how to do it, just forget it. Now, another trick that optimization that I haven't made on this, because I haven't found a big enough contentful space that's going to make this thing take too long to run, is that the entire database is loaded in one transaction, which can take a while on bigger systems. And a thing I found out last week when I was trying to test this utility, it only works on Neo4j 3.5. During the conference 2 weeks ago, I mistakenly installed the Neo4j 4 and wondered why my system broke. Now, I haven't had time to fix it up yet, but at some point I will. So this is the thing on the mappings. Now, this is how the mapping for the system works. There are assets, which are the video files or images or zip files. There are entities, and there are the relationships between them. So to start with, I load the assets, then I loaded the entities, then I load the relationships. And this got me 95% of the data fed into the system. So, for example, scalar properties in Contentful became properties on the node. And you can in Neo4j, which I found out it's quite an interesting one. You can actually put arrays of scalar data into Neo4j. Then you've got the entity relationships. They become relationships to other entities. And if you want to record the order of an array, you just stick them as properties on the relationship, and it's all entirely sortable. Now, this worked for 95% of the data, because I started finding there were weird special characters that were broken. So I just had the system was scripting them saying, hey, I can't handle this. And I started trying to work around, oh, how do I fix this field up? And how do I fix this field up? And especially we got fun when we had one article that got translated into 27 languages. And I think there was something like 15 special Unicode characters needed to do that, just to get the umlauts and accented characters there. But then I started using a parameterized query, and this just handles everything. And this solves all the problem. So then I simplified how the system works. So then I load the assets first, then I just add a bare bones entity, and then I add the relationships and add all the properties to the existing item one by one. It makes it slightly slower, but it means there's no special cases, no special logic, everything just works. And there's a magic is that Neo4j is, Neo4j has a bigger data storage capacity than Contentful, so there's never going to be any limit, any data I can't store. Now, this is the other fun stuff I found while writing this, is that Contentful is highly rate limited, so on the free tier. So you need to throttle and cache your reads. So find somewhere caching the data, read it only when you need to. There's a size limit on each page of data which is fetched, but as I'm reading all the data piece by piece, it's not a problem. It was fun working with JavaScript promises, because trying to test a promise is fun, and I learned a lot about that. And again, I would need to learn all the assets and all the entries, guarantee the relationships will work. And then I also found that the Neo4j drivers aren't very good at telling you something's wrong, but not always what's wrong. So I had to do a lot of interesting debugging to work my way around through the pieces. So let's go through a demo of moving that database I created earlier into a graph database. So showing you here is my graph database, and I'm going to do the classic delete. So match A, R, A, let's see if I remember how to write a query. A, R, B, delete R, and it's match. It's probably an easy way of doing this, but I'm in a hurry. A, delete A. Spell delete. Right, okay, so I've now got my utility there, completely empty database. So let's start with this utility. So right, so here's my query of how to load a database. Right, so I've got my details here of a yarn load. So basically, here's the space ID. This is basically, because I'm using a Mac, I can pass in environment variables ahead of the item I'm doing. So here's the space ID, which is the name of the database I'm using, the contentful access token I've generated, and my password, which I don't care, everyone knows for the locally. My local password is Magic Beans. I only use it for silly demos. So, right, let's run that in. So it loads it in, fetches the contentful data, and loads it into the graph database. And this requires 15 megs of RAM and took 3.5 seconds to load in. So I can do match A, return A, because I've got a nice small database. And then you end up with the entire of a content management system. Sorry, trying to work out which button I've done there. Match A, return A, there. I then have, well, sorry, I'm trying to get the details right, which is the full screen there. There you go. I now have the content management system that I created, and you can see the properties on there, and that's got the archive true property on it that I set up and added to the content management system there. So this is a graph that can show the entire data of the content management system with all the properties in it, and it took 2.5 seconds to load up. So that's the beauty of moving data across. And by doing so, I was able to start asking questions and immediately see I can put up the business rules to actually say how many of these items are linked to this item. So I can actually see, it's really obvious to see that I've got an unused asset that is not used by anything on the site, which is an incredibly useful thing to be able to find. I can find broken links. I can find out how many things, how far away from the homepage everything is. It's easy, and you can start doing all the amazing graph queries that you know and love. Right, so let's go back to the presentation, see what else I've got. So going through, that's how you move the stuff through. So at that point, I'm going to kind of stop it slightly early and go for questions. So I'm going to hand back to Lou.
Thank you very much, Chris. That was brilliant. So we'll take questions, but we're going to do them after the next presentation. Then we're going to do them as a panel. So thank you very, very much for that. That was great. And now we are going to go over to Tim. So Tim, over to you.
Yeah, thank you very much, Lou. Yeah, I'm Tim Reimer. I'm actually an independent consultant and specializing in system integrations. I have done this for a long, long time. And now I'm actually also, as a side note, I'm doing my PhD, and I'm a PhD candidate with the University of Calgary in the electrical and computer engineering department. Kind of an off because I'm focusing on software integration or application integration. And so my talk here this morning is that we want to look at some of my work that I'm doing in regards to my research, and it's focused on semantic transformations in enterprise application integration using graphs. When we look at EI, the whole problem is that we want to send messages between all the different applications as well as external business partners. And normally what we do is we have these messages that we construct. So for example, and they can be in different formats, XML, and then they basically get shipped through a middleware to the target system, and the target system responds with an acknowledgement and so on. So we build that network of messages that go through the corporation. And when we look at this enterprise application integration, I always say that we can break this down very easily into three major components. There's this component of transportation, which is basically sending messages from A to B, and that's the routing of that message, and we're talking about context and message-based routing at that level. And then we have the second component, that's the transformation, which is taking the message, say an XML message, and putting into a CSV file or into a database or a JSON message, and translate that over. And we differentiate there between syntactical and semantical transformation. So the syntactical side is a structure component where we change the structure of the incoming message to the structure of the outgoing message. And then we have the semantical transformation, and that is much more challenging, because here we are translating meaning of data into the meaning of for the target system to understand. So very easy. I always use the example of the unit of measure, right? So you can have a unit of measure in the source system to be kg or BR, which is barrel, and then you have a target system that has the same unit of measure but has other code as a BBL. And the third component of enterprise architecture integration is the orchestration. So in many cases, messages have dependencies. So for example, if you send orders across, you want to make sure that a customer is there first. And so you build these workflow, and there's usually in the common middlewares, there's a workflow tool that allows you to build these orchestrations. When we look at the overall architecture of a traditional enterprise application integration platform or enterprise services bus, basically we have a whole bunch of adapters on the receiving side, and then we have a whole bunch of adapters on the target side, and in the middle you can see the three components that make up EI, right? And what for the semantical transformation that we're doing today most often is that we use cross-reference tables, so either a database, and we say, okay, here's a key value pair. So if I have a unit of measure of BR, capital BR, coming in, I go into this table and I look it up, and then find the receiving target system that has the respective value for that BR, and then I turn it around and populate the target message and send it out. Now, the problem with that is that we have a lot of tables that we have to maintain, and it's all everybody has to maintain. We have to have people who maintain that. It's a business function. They don't understand the data itself, so we have to train people. All of this has to be continuously be maintained. So it's a very much human work that has to happen there to maintain this table. Those tables and data structures. And so that's kind of where I said, okay, well, is there a way that we can automate this whole process or semi-automate it and come up with a way that the system actually learns so that we can handle these cross-reference tables more automatically. So to give you an appreciation, here's one that sends pipeline data across, and we have a whole bunch of transactions coming through every day. We have different types of transactions, and you can see the value. Sometimes we have 6,000, sometimes, and this is all real time with web services. And in this particular case that I'm using as my use case here for my research. So anyway, the problem space is in this is more in the semantic transformation area, because syntactical transformation, that is, we have that under control. There's a lot of functions that are available that you can apply in order to do the translation between, for example, CSV and XML file. But the more challenging part is to come up with some kind of an automation for the semantic transformation, as I explained already. Okay. So the problem with the current approach is challenges in adding new applications. Okay, so every time you have a new application, you have to add new cross-reference tables. You have to design this whole process. Especially with tables, it is very rigid, like especially when talking RDBs or relational database, to make changes. And these cross-references or reference data that I'm talking about is very dynamic. It changes constantly. Structures are changing and so on. And then we have to also deal with entropy, right? So if this is not properly maintained, it loses on value. And every time we don't find a proper cross-reference table, entry, the message will fail, right? There's simply, that's what's going to happen. So there's a hard cost for the business to deal with that, because if an invoice doesn't get translated or shipped properly, you can imagine that is a direct cost to the business. And then, of course, we have manual maintenance, as I already alluded to, and all of that is very much error prone. So the question is there a better way? Is there a way to define a cross-reference schema so that we can maintain these schemas autonomously? And is it possible to inject AI into the cross-reference logic so that the system will learn and adjust its relationship autonomously, or at least semi-autonomously? Right? So here's an example. I'm not going to go through what the table is. It's just a typical RDB that has a whole bunch of tables, and they're connected, and there's relationships. And so we have material here, we have locations, we have pipeline data, and so in this we have a unit of measure, we have the source system application. So what I did is I took this scenario and I said, okay, here's a typical RDB database that we use for our lookups and for our for this reference data. And I took that and I basically created and thought, okay, let's do it with a graph. And I converted that into a graph in Neo4j. And so that's basically the graph that came out of it. So this is a direct conversion from the RDB to the graph, because that's the fastest way to do that. Then I said, okay, well, let's look at the architecture again and see what we can do. So the first thing I did is I basically build an abstraction layer in here that says, okay, we're going to create another server which runs the graph database. And then what we're going to do is we're going to attach another module to it that does some machine learning exercises against that graph, against the transaction data that we're receiving. And then we can start predicting if we have a failure, we can start predicting of what the outcome should be. And then the idea is basically go back and update the graph. So here's, with this database, there's some preliminary stats that I did in order, and I took, I think in this case, I took 3 different algorithms right now, logreg, KNN of 3, and then support vector machine, in order to show that already with 10,000 transactions, we get pretty good, pretty good hit rate and accuracy of it from predicting what the value should be when we sent these transactions through. So that was my first attempt. And so I went off and I said, okay, let's take a little closer look at what actually happens when we do cross-referencing. And it's very interesting. In this analysis, I came up with four distinct patterns that are happening. And the one pattern is a one-to-one relationship. That's a really easy one, where we have a source value, a key value, and then we do a lookup, and then we find the target value for that. So if you have a source system that has a material code, and then a target system has a different material code, that's really easy to look up. So that's what I call the one-to-one. Then we have another scenario where we have a source system that sends us a value. We look it up, and we need additional data that is not that the source system doesn't provide. So, for example, a typical, using a material again, we have a source system, we look up the target material code, and then we want, for example, the material description, or we want some other characteristics or attributes of that material, and then we populate that into the message to add to the target system so that it understands. And then we have the dependency pattern, and that is where we have the source system has a value, multiple steps. That could be a combination. So if we want to look at material and we have a location code and we have a pipeline code and pipeline segment or tankage or whatever, and that drives us to an asset ID, for example, right? So there is a combination of events that happens throughout this lookup, and that's the reason why we have a relational database and how we hook that all together, and in order to get the target value. And then the fourth one is the granularity. And that's more of a tricky one, because in this case, we have a source system, but we have multiple options for the target value to determine the target value. And the only way we can, of course, do that is somehow to determine that what kind of condition record that is, that we have a condition record that determines what the target value is. Now, in many cases, that is usually a date-driven, right? So in my case here, I can have a material code coming in X, Y, Z, and then I have, and that could be for petroleum or gas, right? And the output side could be, winter gas and summer gas. And based on the date that I receive on that particular order or whatever the transaction is, then I can determine on the date what the actual target material code is, because the winter gas is different code than the summer gas. So that's kind of what I'm talking about when I talk about granularity. So those are the four major patterns that I discovered when we do cross-referencing, and so far they basically cover about 90–95% of all the scenarios that we encounter in cross-referencing. Now, there is also combinations of this. You can have a cross-referencing that happens where you first do a one-to-one, and then you do a dependency, and maybe then granularity, and so forth. So the combinations of hooking these four patterns together makes the complexity of making this lookup. So what I did is I went back and I said, okay, well, we have these four patterns. We have the initial data, the initial graph that we have. I want to build a system that basically does this automatically, that basically creates dynamic cipher and figures out, based on the pattern that I have, basically figures out and traverses the graph and finds the values. So what I did is, what I came up to the conclusion is that a strict conversion between an RDB and a graph is not suitable for this kind of an application. So, and what I said is, well, we have to normalize this graph. What that means, in my terms here, normalization means basically removing any nodes that have mapping characteristics. So if I do, if I try to connect two nodes in order to figure out an end condition, I have to remove that, and I have to basically move this relationship in, move this characteristic inside of the relationship. So I restructured the graph itself, and it comes up to a new normalized graph. Now I have real true entities here, like you can see location, tankage, pipeline. I don't have any more mappings between source and target material. It's all part of the relationship structure that happens. And now, and you can see here, I took a screenshot of how it looks in Neo4j. The next thing I said, okay, well, let's go back and figure out exactly how we can better work with these patterns that I discovered. And so what I did is I said, okay, well, now let's build a new architecture, and that is basically on microservices that are running out there. So these microservices now, I have basically 4 microservices that for each of the patterns. So you're isolating or abstracting, again, the logic for that particular, to support that pattern that I identified. And what happens here is that in the beginning here, the receiving end is an orchestration unit that basically manages, based on the integration scenario that we are talking about or that we are trying to process, it orchestrates the connections of these microservices along and figures out exactly what the sequence and is of invoking these microservices. And the bottom line is that there's an object that is being passed between these microservices in order to define the lookup requirements, and then the microservice goes and builds the cipher query out dynamically, and then goes into the graph in order to find the result and traverses and finds that, and then goes back and passes that back to the orchestration piece, which then passes back to the middleware to incorporate that into the target message that it's sending. Now, the next step, what I did is I said, okay, each microservice will have a process log that identifies exactly how it has traversed the graph. And that is really the important piece, because that we can use then to say, okay, well, we can take this data and do process mining against it. And that's why I introduced a container architecture for the machine learning exercise here for logarithmic regressions and KNN. And I can add any kind of container to do any kind of algorithm that I want to apply to this. And so what happens here is, I'll give you a screen print here, which is very interesting. That is a typical process log that comes out of one of these microservices. And you can actually see here that we have a request. So we have here a link, location code. We have a tankage. Here's and that's a node inside of the graph. We have the property that we're trying to look up. You can see here the lookup value for that location code and for the tankage. And then you can also see here that there's a response property, which is the one that we want to look up. So in this case, we have location code, we have a tankage, and we have a plant code. And the plant code is 60081, and that's exactly what we have looked up. Now we have all this data, and it's thousands and thousands of records that we are generating through this. And we can come down to the bottom here, and oops, here we see that there is an error. So here is a combination of a location code, which is PATK, and we have a tankage of an MTA, but it didn't find the associated plant code because there was no entry in the graph for that. So now what we can do is we can take all of data as a learning set, and train our machine learning algorithm. We can come back and we can predict what that value is, and then come back and I can say, okay, well, now we have the predictive value. I can go back and from here, I read just the log files that I just showed you here. I can run it through the machine algorithm in real time almost, and then basically pass that entry back into the graph here, update the graph, and the next time a transaction comes through and we do a lookup, we have a respective value for that, and we won't get that error. And all this happens without human intervention. It's automatically. So in a nutshell, what else has to be done? Well, this opens up the door to a whole bunch of new opportunities, right? First of all, we can take these graphs now and actually build a knowledge graph for an enterprise on it, right? And that's one of the things that I'm looking at right now is, okay, if we have this this graph that we built here, how can we now take this and build a knowledge network for an enterprise out of this? Can we use this for other applications inside an organization to replace master data management? And one of the things that I've been testing with is Semantics, which is a really cool tool to bring, for example, to create OWL data, OWL structures out of this, and then populate that into a protoj, for example, and build and manage ontologies on that. Then we can, of course, with this modular architecture, I can add more algorithms to it to come up with better ways of finding better ways of handling this problem. And looking at neural networks, for example, that's another opportunity there that I want to investigate. Provide direct feedback and update to the graph with predictions. So as I said to you, that we can update the graph and build an interface that we take this result data and push it right back to prevent future failures. And then can these concepts be used to build a corporate knowledge graph, as I mentioned? So that's kind of in a nutshell, kind of the work that I've been doing, and I wanted to share that with you guys. I think this is very, from my experience working with integration, it's very, very relevant because everybody has the same problem, and what you have to kind of sit down and to start coming up with a solution. And bits of the abstraction that I have here, it's basically I'm building a contained logic that can then be attached to any kind of middleware to do the lookups. Thank you very much.
So I think we've had a couple questions come in. Lju, do you want to lead the question session? I think you might be on mute, Lju. I'm not hearing you speak.
Sorry about that. Forgot to turn my microphone back on. But no, so first of all, thank you very much to you, Chris, and to you, Tim. That was really, really interesting. Really great. I've got some questions as well, but we're going to first go over to the questions that have come up in the chat. And I'll let Nathan ask some questions first before I do my dominating. I've got loads of questions. Excellent. Right. So Telho popped in a couple of questions. So the first one, this is to you, Tim, which is, do you have to use internal IDs for these connections to be unique?
Can you repeat the question? You broke up there for a second, Lju.
Sure. So Teller asked, do you need to have internal IDs for these connections to be unique?
Yeah, I mean, it falls under the normal authorizations, right? So the connections, the middleware is basically the manager of the source and the target system. And what I'm showing here is just one source and one target system. You can have any combination out there, right? You have, I mean, I've seen very, very complex integration scenarios. So for testing purposes, I try to focus on one scenario, and then kind of roll it out. But they don't. It is based on the integration scenario, not on the uniqueness of the endpoints. So if the integration scenario has to be defined in such a way that that we can find the actual values. And I'm working on the orchestration right now piece, and actually I had a major breakthrough to define routing rules for figuring out which microservice actually is going to be invoked. And I'm going to be using a graph as well, just to define the routing of how these microservices are going to hang together, so that we can do everything dynamically. I hope that answered the question. Yeah,
that's really, really cool. And got another question here. I assume this is for Chris. So from Twitch BizCoach, have you found that the number of errors, broken links, etc. have decreased over time as you've used the new integration?
Yes, but we generally were able to find broken items and make them go away. So yes, they do tend to vanish. We're even able to do really weird things. So, for example, some of our articles were color-coded, and we were actually able to find out how many colors were being used for each of the articles and find out unused colors and remove the unused colors for using this analysis tool.
Brilliant. Excellent. And as a follow-on question to that as well, which is, have you been able to identify root cause behind the failures?
Which of us is that for?
For yourself.
Okay. root cause behind the failures. The main root cause behind the failures is that we weren't told to write validation into the system to start with. So it was we just came up with a system of asking questions.
Nice.
So how did you share the information from the system back with the business?
I actually gave them direct access and gave them some sample queries on a wiki page, and they could run the queries themselves.
Oh, nice. Right in the browsers.
Yes, I gave them access. I had a Neo4j graph database, and I just gave them access. And here's the queries. Paste this query in, paste it in there, and run it yourself. And then it's all self-service.
Nice.
Very nice. That's really, really cool. And I guess a quick question for you, Tim. So what I found really interesting is obviously this is fitting into orchestration of the services, and how do you pull the reference data and do the transformation of the reference data that's required as you pass down the bus. But I guess what I was sitting and think about it. Do you see any application of improving connectivity between systems? So obviously you've got things passing between the bus, and if you've got your decoupled systems. But I'm wondering here, do you see this offering any opportunities for sort of improving connectivity between systems? So, for example, if you find out you've got a 5 or a 6-way hop between different systems to transform data, and now you're starting to pull into the graph, and you're starting to have a look at how different points are being pulled. I mean, do you see any opportunities for improving?
Yeah, and what I've seen in all my work with, I mean, I've worked with so many different companies, right, is that they have an integration hub, if you will, which is basically everything flows through that. And that's the right way to do that, because you can monitor messages, and you have ways of, if failures occur, you can do alerting, and you can monitor the business processes themselves. So normally what happens is there is some kind of a hub middleware, or whatever you want to call it, that is available, that you basically, and what I'm seeing is to attach to that, and let the middleware do what it is best doing, which is the syntactical translation between messages and routing the messages. Those are the two pieces that are really, really critical. And then attach this as an add-on and say, okay, here now you can solve the semantical problem by basically doing a call to this subsystem, if you will, that then does a traversal and uses a graph to do that. And I think there's significant potential in there, because cross-referencing is a huge issue, right? And remember, anytime a message fails because it doesn't find the value, that's hard dollars, right? So you want to minimize those failures, and you have, by using process mining, you have a tremendous amount of data that you can figure out exactly what the data is, or make good predictions, right? And I show you some of the early discoveries that I had there, right? So, yeah, that's kind of what I see where this thing is going, or could be going. And then, of course, the add-on is, what I would like to add on is the potential of building a corporate enterprise knowledge network, right? Or a knowledge graph on this, because other systems can take advantage of this logic and information, right?
Yeah, or find applications that aren't being used very often, and finding the deltas between what you think the state of the nation is and what actually is being used.
Yeah, think about banking systems. Think about any kind of supply chain systems. Think about inventory management systems to sales systems. External partners. In this case here, this is a scenario given off by a hub, a broker that basically collects pipeline data from North America and puts it through and pulls it in. It's a tremendous amount of cross-referencing, because shippers on pipeline have totally different material codes than the guy who is actually shipping. The carriers have different material codes, right? So it's phenomenal, right?
Absolutely.
I have a healthcare background. I can see all kinds of applications in healthcare.
Oh, it's huge. Yeah, absolutely. Yeah, I think it's fun.
So, go ahead, Lou.
No, you go for it.
Well, I don't want to go too deep into the weeds on the machine learning, but could you describe a little bit about the features of that you're using with the models that you described?
Well, I just used Python. I wrote some Python code that does logarithmic regression and does a cross-validation of it, right? And then I just
What
build a
features
frame.
did you use to make the prediction?
I use what I get, right? So in this case, for example, location code and what was it? Tankage, for example, right? Those are the two parameters that I need in order to find the plant code. And that's all what I have for that particular scenario in that, right? Others might be different depending on the pattern, right? So again, it looks at the pattern and says, okay, so what are the attributes that I need in order to find the value? And that's kind of how I pull that out.
That makes sense.
Cool. I've got another question for Chris, actually. So you talked a little bit about how obviously you're mapping the various content that you have and the web pages and the linkages. And I guess probably a bit of I'm quite curious, did you identify other opportunities with that? So for example, because you've linked all of the pages in, and I don't know whether you've got sort of click information as well, or the journeys that people take, have you sort of found opportunities where you've identified actually a user journey which was originally 10 hops could actually be 3 hops, and actually you've got loads of people doing these 10 hop journeys, so we should probably simplify our website menu? I mean, have you got that kind of thing?
We haven't actually overlaid, we didn't actually get as far as overlaying the data onto it, so we were mostly playing with content, but it would be theoretically possible to overlay the stuff. But what I was able to do is to find patterns of this article is linked to this article in 2 ways. And then we started saying, well, what other ones aren't linked that way? So we used to have kind of subject hubs that had links to items, and we could find items that linked to another article but did not have a subject, were not in a subject hub. And we were actually able to give the content editors suggestions of future articles they could write to bring the stuff together. So by just looking at the data, we could find the orphans and then start making suggestions about new things to write.
That is super cool. That is really, really nice. It's like a content generating suggestion system. Yes. As well as your content management system.
Yes, using the content management system for actually finding holes in the content and actually generate new articles. So yes.
That is really cool.
Brilliant.
Then one of my bosses also added it on, because we had this kind of knowledge graph of how things hang together. He added an Alexa skill that able to answer questions. Because we had relationships between things, it could actually start asking things about questions in the Harry Potter world. So you can ask the parent of or child of, and we actually had because you can map a Alexa skill rather directly onto the graph. We actually had an Alexa skill that could just talk off the same data.
I love that. That is brilliant. Wow, that is fantastic. So I guess we've got time for one last question. So I'll leave it up to maybe, do you have any questions for us or for each other? Or do you have another question, Nathan, or I can sneak one in myself?
I would let you take the last one, Lou. It's been so interesting to have this discussion.
Okay, so I guess I'm just trying to. I guess the interesting one that caught my attention, Tim, you mentioned graph normalization. So I wonder if you can just sort of go into it a little bit more, because that's quite an interesting sort of phrase that you put in, because obviously if we think from a relational world and we think what normalization means there.
I came up with that word because I don't know if it's the right word, right? I just when I transported, or when I moved the relational data over into a graph, which is kind of a true one-to-one relationship, I noticed that in a relational database, for example, when we want to build a connection between 2 material types, right, the source and the target material, we build another table that basically shows a relationship between those 2 things, right? That's the way. So we have these, what I call these mapping tables, right? And they're all over the place in order to build these connections, depending on the scenario. So when you have these relationships and bring them into a graph, you're going to have those as labels and nodes there as well, right? So what happens is, if you want to do a dynamic query, like build a dynamic cipher that goes basically on true entities from the outside coming in, right? You are not aware of these mapping relationships. You're only aware, the outside system or the requesting system is only aware of true entities like plant, tankage, location. They don't know, it doesn't know anything about any kind of material to material mappings, right? And so that's the reason why I've discovered that I have to remove all that stuff and move it into the relationship itself. So when a request comes in, it can navigate based on the true entity that is out there. So you can then say, okay, I need a location and I need a tankage in order to find an asset ID, or I need exactly a material code in order to find a location code, right? And there's no intermediate level of nodes in between. And I've been able to solve that problem again by using specific relationship types with an attribute or property, with a property to figure that out and to define exactly what the parameters that I need in order to find the path, the traversal path to find the target, the value, right? And that's the reason why I came up with this notion of a normalized graph where all of that is removed.
Cool. Very interesting. Well, we're at the top of the hour, so huge thank you to you all. So thank you very much, Chris. Thank you very much, Tim. Your talks were brilliant, really, really interesting. To everybody who's watching, if you've got questions, pop them in, in the comments in the video, and we'll figure out how we circulate those around. Massive, massive thank you to my co-host Nathan for joining me today as well. It's really great to have you on board and joining in.
It's a great pleasure.
Thank you. And thank you very much to everybody for joining us today. So we will be back next week. So we've got the details on the next scene. So keep an eye out for our next guests. Thank you very much.
Okay. Thank you. Bye-bye.
Bye.